Traditionally, when someone says vaccine, the image of a syringe and needle usually springs to mind. But injections need trained staff to administer them, and they're unpleasant, even for people who are not scared of needles. So, vaccines you can inhale sounds altogether more attractive, and that's what researchers at Rutgers University in the US have been working on. They found a particular clutch of chemical compounds that are very good at passing harmlessly through the lungs and getting into the bloodstream, where they can interact with the immune system. What's exciting about these chemicals is that they can be coupled up to drug or vaccine molecules and used to pull those into the circulation as well, and it might even work for COVID-19. Renata Pasqualini told me how it works.
So what we're trying to do here is create a system of vaccination that people can breathe in an inhaler. We discovered a transport system that allows compounds to cross from the lung to the circulation. Usually when something gets breathed in, it stays in the lung, it doesn't cross over. So the big advantage here is this transport system that we were able to uncover.
How did you find the magic compound that could do that lung cells would transport into the circulation? How did you find that compound in the first place?
Once the compounds got into the lung, we selected for those that were in the blood by looking for them directly.
Was it an enormous tour de force then? You just started with a big jumble of possible compounds and just tried them one after another and picked the ones that looked the most promising?
Yes, the beauty of the system is that you can select and zoom into the compounds that have the ability to cross from the lung to the circulation.
And how would you use this then? Would you couple those compounds that you found that now have this ability to direct things through the lung and then into the bloodstream onto something that you want the immune system to pay attention to? So you've basically created the Trojan horse that gets the Greek army or whatever that you want the immune system to fight into the body.
Yes, so there are two practical applications here that come to mind immediately. Number one is the ability to administer therapeutics in this way. So say insulin or something like that. And the second application is the development of vaccines that are potent and can be given in this convenient way through an inhaler.
It's clever that you can basically use the same know-how to get a whole range of molecules into circulation, not just things that the immune system wants to know about. A couple of things arising from that I'd like to ask you about then. The first one is, how do the lungs take to this? Are these compounds that you're using to get the chemicals across the lung friendly?
Yes, this is a system that has been shown to be very safe. And one of the advantages, again, is that other systems in which you inhale something often damage the lung and kill the cells or make them unhappy. In this system, we have these compounds that are fairly safe, and they are able to go through this transport without damaging the lung cells in any way, shape, or form.
So next question then, if you do couple up something like insulin onto one of these compounds so it gets into circulation really effectively, does having this extra compound linked onto the insulin affect the ability of the insulin to do its job?
Not necessarily. This would be a chemistry exercise in which you are able to preserve the activity of the compound and the transport system.
And does it actually work? Have you actually got things into the body in some kind of animal that's, relatively closely related to a person, let's say, so we know that this can work and is a viable, valid strategy?
Yes, the selection system was performed in mice, but then validated the leads, the most powerful entities that had the ability to cross the lung in rhesus monkeys, which are exceedingly similar to humans.
So what did you actually do with the monkeys that proves this can work and has got the potential to turn out, say, vaccines I could inhale?
We took the most potent particles and administered them to rhesus monkeys. And we looked at the blood and were able to validate that they were present at very high levels.
But you haven't yet taken the next step of, for instance, coupling them up to a hunk of flu virus or even coronavirus and demonstrating that they could carry in bits of dead virus and make an immune response against those?
That's the next step. As a matter of fact, we do have an evolving program in the laboratory that aims to accomplish that. And we are in preliminary phases of validation in the sense that we are introducing small pieces of the coronavirus into this entity in order to attract the attention of the immune response and produce a response that would recognize coronavirus and neutralize it.
Because in theory, something like that you could send out to patients through the post and they just breathe it in, would be a wonderful way to solve the real big headache we have right now, which is how to get vaccines into whole populations at the sort of scale and with the speed we need to.
Absolutely. And again, the advantage I would like to mention is, number one, very easy to make in very large scale, safe, pure, and also doesn't require a cold chain, doesn't require refrigeration to be distributed, so as to be available to a global population at a very large scale.
Sounds amazing. Let's hope Renata Pascalini, who you heard there, can pull it off.